Welcome to Raytown Chop Shop. I'm still Mike.
And I'm still Austin, and this is part 2 of the KawaBunga build, the Kawasaki Ninja 250 powered go-kart. In this episode, we'll install the new rear axle and mount the engine. There'll be cutting, welding, fabricating, and even a little lathe work. Come join us as we build this monstrosity.
We had to take the go-kart off the sawhorses and put it on the floor because we couldn't lift the Kawasaki frame and engine high enough. With the engine and frame precariously positioned, all of us racked our brains trying to figure out how best to mount it to the go-kart. Well, it's time to install the new rear axle from Go Power Sports. First order of business is getting rid of the old bearing mount. The tricky part is grinding off the mount and the weld without getting into the frame rail.
Grinding as much as we could and not damaging the frame, it's time for a little friendly persuasion. The dead blow hammer doesn't seem to have much of an effect. A friend of mine, Lee, gave me this crescent wrench as a joke that he thought we could never use it seriously. Turns out he was wrong.
Archimedes once said, "Give me a place to stand and a lever long enough, and I will move the world." I think Austin proved him right.
Once we decided we could actually install the engine into the go-kart, it was time to install the rear axle. First up, deciding on the final placement of the rear bearing plates. If we ended up putting the rear axle under the go-kart frame, the rear end would be way too high in the air. So the plate goes back to our original idea. It's time to start mocking up the rear axle. The new bearings go on.
It's kind of important that the rear axle is perpendicular to the go-kart frame. So, Austin and Chris double check the alignment. Austin has already tack welded the bearing plate on his side.
Once we had the rear axle placement where we wanted it, I tack welded the other bearing mount.
Looks like the boys got it lined up correctly.
Now that we're happy the go-kart is going to go relatively straight down the road, we removed the rear tires so I could do the final weld on the bearing plates. I didn't want to overheat the bearings while I was welding, so we decided to take them off. The same goes for the rear axle. We have way too much money wrapped up in the whole assembly to ruin it now.
And the final welding begins.
Chris and I clean up the welds. We're going to use the original Kawasaki brake rotor on the go-kart, so I cleaned it up on the wire wheel. I took one of the axle hubs ordered from Go Power Sports and turned down the outside edge until it fit perfectly inside the brake rotor. Then I welded it solid to make sure it would ride on the rear axle. After welding, put the whole thing in the lathe to make sure it was running true. Looks like it's gonna work.
Austin took the original sprocket from the go-kart, centered it with the Kawasaki sprocket, drilled the necessary holes, and bolted the two together. This way, the keyed original sprocket and the motorcycle sprocket will work as one on the rear axle.
We put the rear axle, sprocket, and rotor into the bearing mounting plates. We slid the rear wheels and tires onto the axle. Looks like everything's gonna work just fine.
Once they were sure everything was going to work the way it should, Austin and Chris bolted the bearings into the mounting plates.
Once the rear axle was secure, we slipped on the rear wheels and tires again.
The boys have been working hard, so it's time for a little relaxation and silliness. When it was finally time to get back to work, the boys cut the flat bar that was going to become the new engine mount plates for the Kawasaki.
When we mocked up the engine into the go-kart frame, we realized we had a clearance issue. The original crossmember in the go-kart was preventing the engine from sitting low enough and the chain would rub. We cut out the original crossmember and fabricated a new one, allowing the engine to be mounted lower, lining up better with the rear sprocket. With the flat bars cut, Chris and I put them on the go-kart frame using the crossmembers for support. These are going to be the foundation for the engine mounts. With the engine mounting plates in place, it's time to cut the tubes that will support the front of the engine. We measured the tube and began cutting. The first of 2 tubes was ready for mock-up.
As you can see, Chris holds the tube in place while Austin figures out the angles that need to be cut so the tube could be welded to the secondary engine mounting plate.
I ground down the tube until I had the angle right. On the other end of the tube, I used a jigsaw to cut a sharper angle. I'm going to weld this piece to a flat bar, drill it, and bolt it to the engine using the original mounting point on the bike. Looks like it's going to work just fine.
What goes on top of the engine mount tube is a piece of flat bar. Here, Austin grinds away the sharp corners for safety and clearance issues. Once the flat bar is shaped correctly, Chris drills the hole that the engine mounting bolt will go through. With the tabs ready to go, the boys double-check the clearance by installing the engine mount bolt through the tabs.
Now that we're happy with the tube, I tack welded the bottom of the tube to the secondary engine mounting plate. I made a quick tack weld at the top of the tube. Now the top of the tube has a piece of drilled flat bar attached to it. We'll run a long bolt through the flat bar, the engine, and over to the other tube.
With one side done, it's time to fabricate the engine mount tube for the other side.
After a couple trial fits, I marked the tube again where it needed to be cut some more. For the second engine mounting point, we used a hole where the Kawasaki swing arm was attached. Since it was low on the frame, all we needed to do was cut, drill, and weld some flat bar.
The only problem with using the swing arm mounting hole for an engine mount was the hole in the frame was huge. Austin took some measurements and came up with the dimensions of a couple of spacers that would fit the holes.
To make the spacers, I used a bar of aluminum that I picked up at Metal by the Foot. Time to turn the aluminum down to size.
It's always a good idea to check your measurements on a pretty regular basis. Last thing you want to do is shave off too much and have to start all over.
Once the aluminum plugs were turned down to size, I drilled the center hole where the bolt would go through. We haven't quite decided where we're going to mount the very back of the engine to the frame. One idea was using the bike's monoshock.
Time to drill for the engine mount bolts. Center punching's a pretty good idea when it comes to drilling metal.
I have the primary and secondary engine mounting plates centered so I have room for adjustment. Time to drill through both plates.
After figuring out why my plasma cutter wasn't working, seems you ought to change the filter more than once every 10 years, the boys put me to work cutting off excess pieces of the bike's frame, like the kickstand mount and the passenger peg mounts. Note the aluminum plug right above where I'm cutting. This is one of the spacers Austin turned for the lower engine mount. I can't stress enough how important the alignment between the sprocket and the engine is. If they're not lined up perfectly, the drive chain is going to fly off the sprocket at the most inopportune times. I used a length of flat bar as a straight edge and drew in the lines for the adjustment slots that need to be cut in the primary engine mounting plates. From the holes Austin drilled, I'm measuring and marking the length of each slot. If one slot is longer or shorter than the others, we won't be able to adjust the chain tension properly. One of the best tools I've ever owned. Thanks to my lovely wife Carlin for buying it for me at a car show in Ottawa, Kansas many years ago. The folks from Miller had set up a booth and were demonstrating how to use the plasma cutter, and I knew I had to have one.
We clamped a length of flat bar to the primary engine mounting plate and used it as a guide. One slight drawback of using the plasma cutter is the slag it produces, sometimes causing the metal to be stuck together. But not to worry, the slag pops off easily.
For any of you who are completely confused by how this crazy engine mount really works, this shows it pretty simply. The secondary mounting plate sits on the primary mounting plate, which is welded to the go-kart. The long tube welded to the top plate bolts to the original mounting holes on the Kawasaki engine. The flat bar welded to the top plate bolts to the Kawasaki mounting hole for the swing arm. Now, it's just a matter of inserting a few bolts. With the slots on the bottom or primary plate, the engine can be moved forward or backward in order to get the correct tension on the chain.
Part 2 is now in the can. As it sits, the Kawasaki frame, engine, and gas tank are exactly where they're going to be when the project is all done. The front half of the go-kart, however, isn't.
In case you were wondering, this is a '67 Mustang Fastback. It's next in line to be rebuilt from the ground up. Right after we finish restoring a friend's '78 Honda 750, building a cafe racer out of a '79 Honda 500, do some fine-tuning on my 33 Willys, and connecting my two shops so we'll have a whole lot more room to work. In the meantime, we'll continue working on the KawaBunga.
Thanks for watching. We hope you enjoyed the build. On the next episode, we'll cut the go-kart in half and make it a whole lot longer.